Welcome, part 4. Let's do this. Volume. Okay, in volume, when we're talking about a cone, our volume's cut into a third. And we get pi r squared times the height. Okay. Our radius here, we don't know the radius. I have 40, I have 41, but I don't know the radius, so I have to use Pythagorean's theorem again. Okay, if we do this correctly, we get 9 as my radius. This is going to be 1/3 pi 9 squared times the height of 40. Do that in our calculator, 9 squared times 40, and then we're going to take a third of it, and we're going to get our volume to be 1080 pi, and this is going to be cubic centimeters. Okay? So very important that we know those formulas. All right, let's carry on. Surface area is going to be pi RL plus pi r squared. Okay? We're going to go ahead and solve for this by doing pi times 9. The slant height is 41 plus pi r squared. So 9 times 41 is going to give me 369 pi plus 81 pi. And we get 450 pi square centimeters. Okay. So there we go, nice and neat. We got all of our work right there. Okay. Surface area and volume of a pyramid shown below. Okay. For this one, again, we're going to use that 1/3 business for our volume, but it's b times h. So whatever the base figure is. In this case, the base figure is a square. So this is going to be 18 times 18 times the height, which is 20. We're going to take 1/3 of that. So 18 times 18 times 20 divided by 3. And we're going to get our volume to be 2160. And this is going to be in cubic centimeters. Okay. Surface area. Okay. Surface area is going to be 1/2 P times L plus big B. Alright, the perimeter is going to be 18 plus 18 plus 18 plus 18. We got 4-sided figure, it's a triangle. Or sorry, a square. Now I need to find my slant height. If you look at this triangle here, if I draw a line this way, my slant height would come down right here and actually formed a right triangle in there. And the right triangle would actually be like this, where this is the height. This would be half of the distance at the base, so that's going to be 9. And here's my slant height. So I just got to do Pythagorean's theorem and solve for the slant height. So I got a calculator working for me over here. And unfortunately, we don't get a perfect square. We get 21.9 to be L. And we're just going to go with that as our rounded kind of answer. Plus the area of the base, which was 18 squared, is 324. So let's go ahead and put all that into our calculator. And we're going to get 72 times 21.9 divided by 2 plus 324. And we're going to get 1,112.4 square centameters for our surface area. Okay? That one's quite tricky that we had to go ahead and utilize that Pythagorean theorem to find the slant height. Okay. 48. Find the surface area and volume of a sphere that has a diameter equal to 24. That means the radius is going to be 12. I'm not going to mess it up this time. Surface area and volume. Volume is going to be easier to do. Okay. Volume is 4/3 pi r cubed. And surface area is 4 pi r squared. Okay. All we have to do is plug in our radius to both of these and do a little bit of calculations. Okay. So 12 raised to the 3rd power divided by 3 multiplied by 4, and we get 2,304 pi. and that's in cubic centimeters for volume. And then the other one's going to be 12 squared, which is 144 times 4, which is going to give me 576 pi square centimeters. Okay. 49, write down the ratio for scale factor, surface area, and volume. So I'm going to go ahead and just section these off here real quick. Scale factor for a normal one is A to B. Surface area is A squared to B squared. And volume is A cubed to B cubed. The problem below asks us to basically solve all three of these given the middle one, given the surface area ratio, which is 16 to 49. Notice I'm lining it up with the ones above it still. Okay, so if 16 to 49 is my A squared B squared, if I were to take the square root of it, I'd go back to my scale factor. That would be 4 over 7. That's how I get my scale factor over there. And then to get back to here, this would be the equivalent of 4 cubed to 7 cubed, also known as, I believe, what, 64, sorry. 64 on the top, and I think this one's 343. So we get 64 over 343. Alright, there it is. Okay, so we're going to stop it right there.